What is rate limiting and how do you implement it in a large-scale system? Rate limiting is a technique that controls how many requests a client can make to your API or service within a specified time window. Without rate limiting, a single malicious user or a buggy client could send millions of requests to your server, overwhelming it and making your service unavailable for everyone else. This type of attack is called a denial of service attack, and rate limiting is your first line of defense against it. There are several common algorithms for implementing rate limiting, each with different trade-offs. The fixed window algorithm divides time into fixed intervals like 1 minute and allows a maximum number of requests per interval. It is simple to implement, but has an edge case where a user can send double the allowed requests by timing requests at the end of one window and the start of the next. The sliding window algorithm fixes this by tracking requests in a rolling time window that continuously moves forward. It is more accurate than fixed window but requires more memory to store the timestamps of recent requests per user. The token bucket algorithm gives each user a bucket that fills with tokens at a constant rate. Each request consumes one token. If the bucket is empty, the request is rejected. This naturally allows short bursts of traffic while enforcing a long-term average rate, making it ideal for APIs that need to handle occasional spikes gracefully. The leaky bucket algorithm works like a queue with a fixed drain rate. Requests enter the bucket and are processed at a constant rate regardless of how fast they arrive. Excess requests that overflow the bucket are dropped. This produces very smooth and predictable output traffic. In distributed systems, implementing rate limiting across multiple servers is more complex because each server only sees a fraction of total traffic. The solution is to use a centralized fast data store like Redis to track request counts across all servers in real time. Redis atomic operations make it possible to increment counters and check limits safely without race conditions, even under massive concurrency. Rate-limiting responses typically return an HTTP 429 too many requests status code along with headers indicating the limit, the remaining count, and when the window resets, so well-behaved clients can back off gracefully. Follow DevVerseX for more daily interview questions to level up your career.